There is nothing new with this technology. Sun always existed and has always been used. Sun concentrators have been used since antiquity. Sun storage heat devices has been known since antiquity, starting with sand. The only new thing in here is putting all those things together in a very efficient manner using nowadays technology. So let me introduce to you Michael Jordan. He is 2.2 meters tall and will hang around the Sun machine. This parabolic antenna is made of stainless steel, very sturdy design, of many elements bolted together. On a frame that can rotate and tilt according to the needs. By doing so, with simple electronics, can follow the sun from sunrise to sunset to have best focusing the rays into the main reflector. So the whole dish will be sending and focusing all the sunbeams into this reflector. That will reflect them in an almost laser-like beam in a hole that's in the center of the parabolic antenna and leads to the heat exchanger. Into the heat exchanger, the beam hits an aluminum bar that is buried in a pipe that resists 2000 Celsius degrees. At temperatures over 600 Celsius degrees, the aluminum bar melts and becomes liquid. The aluminum bar will transfer the heat due to its property to get very fast heat transfer all along it down through the graphite block that also has a property to transfer very fast the heat. So the graphite block will pile up the heat starting from ambient temperature and up to 1700 Celsius degrees. The graphite block is in a special container, triple walls, vacuumed in between, so the heat stays in the graphite and will not be dispersed in the outer area. In the process, the deflector on top of the antenna will lose some of the light into piling up heat. Therefore, it has to be cooled down, otherwise it could melt. Cooling down the reflector will transform water in steam. Therefore, a first electricity producing complex is on top of the antenna, about 100 kilowatts per hour, where the steam passes through a turbine that spins a generator and gives electricity. The second block is the heat exchange device. The heat exchange device that I designed like a monoblock here is basically a heat exchange thing where the molten aluminum will transfer the heat to molten salts that cannot take 1700 degrees. They would get ruined over 700 degrees. So basically the aluminum will transfer heat to them, taking them to about 600 Celsius. In the secondary exchange, the molten salts will transfer their heat to the water in the same block, taking the water at around 400 Celsius degrees, thus transforming it in steam. In the process of the ray beam going down to the graphite block, this heat exchanger will get hot. Therefore, during the daytime, the excess of heat in the heat exchanger will be transferred to the turbines that are around it to make electricity. In our case, there are 4 turbines with 4 generators around the heat exchange block. So, first thing in the morning, when the parabolic antenna will start focusing the sun, the top generator will start producing electricity. After about 20 minutes, the generators in the heat exchanger will start producing electricity, while the rest of the heat will be transferred down through the aluminum bar in the graphite block. In the night, there will be no more sun, but unlike the photovoltaic fields, this machinery will keep on producing electricity because we reverse parts of the process. Therefore, the aluminum bar will collect the heat from the graphite block and pass it into the heat exchanger to the molten salt, which in their turn will pass it to the water, transform it in steam, and keep on producing electricity with the 4 generators for all night long. If the electricity is not needed, one option is to sell it to the grid. The other option is do not use the generators. Simply leave the heat get stored in the block for days or even for weeks, waiting for that night when you really need it. The steam that's coming out of the electricity turbines will be around 250 Celsius degrees. That's hot enough to power cooking ovens. Therefore, a pipe will take that steam and pump it into a cooking complex, where on industrial stoves and ovens the food can get processed before canning it and selling it to the supermarkets. Therefore, vegetables and meat can be processed with the residual heat of the steam. After passing to the process of the food, the steam will lower very much its heat, will get below 100 Celsius, so it turns back into water. Water will be pumped in the FEE system. The FEE system is basically a reverse heat pump of Italian invention, recently patented a few years ago. The FEE system can collect heat from every source, even very low temperatures, and transform it into low energy. So basically, it can produce shower rate hot water, but reversing the pump, it can produce refrigeration. Therefore, the residual heat in the water will be mainly used into producing refrigeration that in part can be used for air conditioning the houses, but in great part can be used into freezing, storing of food that has been or will be processed. Therefore, we can freeze the food without the use of electricity, just by the use of the FEE system and the residual heat in the water. The total cost of this technology, it's about the same for an equal kilowatt power of photovoltaic plant. The total output of the system is much more. Advantage number one, it doesn't depend on the permanence of sun, because we can store energy in the graphite block by the day and use it by the night, or if we have enough energy during the night, we can keep it hot for days and weeks until it's needed. The other advantage is that for each kilowatt of electricity we produce with this machinery, at least other 2 kilowatt of heat are coming out through the pipes that we can use in the industrial cooking or domestic cooking into the FEE system, providing refrigeration and providing air conditioning within 1 kilometer around the parabolic antenna. Such a parabolic antenna of 25 meters diameter can constantly produce in the night around 300-400 kilowatts per hour. A farm of those antennas could go up to several hundreds of megawatts per hour. It depends on the number of the antennas you are placing. As the surface on the ground is taking much less space than photovoltaic, therefore all the space around is useful for agriculture or for raising the cattle. It can stand very well the desert conditions, although it's recommendable at least once a year to repolish the antenna so that the efficiency of sun concentration will be kept constant. Operators can easily maintain the steam-driven ovens without having the dangers of the gas-driven ovens, and not even the dangers of electricity-driven ovens that can provide electroshock. The FEE system maintenance requires a qualified person in refrigeration, but the same person will be able to do the maintenance also for the freezing plants. For the rest of the system, apart the electricians and several mechanics for the bearings and other mechanical components that turn the parabolic antenna, no special skills are needed for the maintenance. Every farmer is able to repolish the surface or to clean the sand and the dust. There are no critical materials, and as long as the graphite will not get in touch with oxygen, it can stand temperatures up to 2000 Celsius, no problem, for about 10-20,000 cycles of heating and cooling before being damaged and needing to be replaced.